By the year 2030, humanoid robots will replace 50 million jobs.
I mean, when you actually model that out, the math is just brutal.
Right. We are talking about a $100,000 machine. It works 20 hours a day, 365 days a year.
Which, creates a 14-month payback period.
Exactly, a 14-month payback period. We have spent trillions of dollars giving artificial intelligence a brain, but what happens when you give it a body?
Well, it's the ultimate convergence, right? Software hitting physical reality.
Yeah. And more importantly, who actually controls the hidden microscopic components that allow it to move? Because that's the real bottleneck.
Exactly. We are watching this massive transition from digital intelligence to kinetic intelligence. And the unit economics are forcing this deployment at a speed the market really hasn't priced in yet.
Welcome to the deep dive. So today our mission is to analyze this physical AI boom, right?
Yeah.
The trillion-dollar labor shortage and the sudden, wildly disruptive arrival of what the industry is calling embodied AI.
Yeah, the shift is happening now.
Right now. So we are going to unpack the wealth building playbook here. We're looking strictly at the data, the margins, and how you can position yourself as capital expenditures shift entirely toward operating expenditures.
Which is a massive shift for business owners.
Huge. But you absolutely must stick around for the second half of this analysis, because we are going to explore the dark side of this revolution.
The societal impact.
Right. The geopolitical arms race for manufacturing sovereignty and this impending blue-collar displacement shock that will permanently alter the macro landscape. But to understand why this robotics boom is happening right now, we actually need to look away from the tech sector entirely.
Yeah.
We need to look at actuarial tables and human demographics.
Precisely. Because if you only look at the silicon chips, the neural networks, the VC funding, you miss the systemic catalyst entirely.
You miss the why.
Right. The global economy is currently facing this profound mathematical crisis regarding human capital. The developed world, and honestly increasingly the developing world, is running out of working-age people willing and able to do heavy, repetitive lifting.
Right.
It's a demographic reality that, frankly, no amount of software code can solve on its own.
So we are looking at the inversion of the global population pyramid, what's commonly referred to as the silver tsunami.
Exactly. The baby boomer generation has been the backbone of global industrial labor for decades. Logistics, manufacturing, you name it.
They built the modern economy.
They did. They provided this massive surplus of labor that defined the late 20th century economic expansion.
Yeah.
But now, they are retiring en masse.
And there's no one behind them.
Right. At the exact same time, birth rates across the developed world have just collapsed, well below that replacement rate of 2.1 children per woman.
Which is terrifying from a macro perspective.
It is. We just do not have a corresponding generation of 20-somethings entering the workforce to replace those retiring machinists, the welders, the warehouse operators.
So young people just don't want to work in a loud 100-degree automotive stamping plant.
Can you blame them? They prefer digital air-conditioned environments. So the fundamental dependency ratio, the number of non-working people compared to working-age people, it's breaking the industrial model.
Okay, but I want to introduce some friction here just to challenge that.
Sure.
Because the prevailing narrative you hear in the media, right, is that factory automation is simply the result of greedy corporations trying to squeeze out a few more margin points by firing humans.
Right, the standard anti-corporate line.
Yeah, so are you saying this is not primarily a cost-cutting measure? Are we looking at a scenario where they literally cannot find the human bodies to keep the assembly lines moving?
That is the exact reality on the ground. You can see it in the labor participation data. It is an existential threat to these industries. If you review the earnings calls of any major logistics operator or manufacturing firm right now, their primary bottleneck isn't access to capital.
It's not consumer demand either.
No, it is labor availability, and it goes way deeper than just a low unemployment rate. You have to look at the actuarial costs of human biological limits.
How so?
Well, when logistics companies are forced to hire from a shrinking pool of available labor, they often have to bring in workers who are not physically conditioned for the grueling reality of the job.
Right, walking 15 miles a shift on a concrete floor while lifting 50-pound boxes.
Exactly, which leads directly to skyrocketing workers' compensation claims.
So the margins get eaten alive by medical costs.
The actuarial data shows escalating premiums across the logistics sector over the last 5 years. Musculoskeletal injuries are destroying profit margins. And furthermore, relying entirely on biological humans creates this extreme brittleness in the global supply chain.
Oh, we definitely saw that exposed recently.
Right. If a respiratory virus sweeps through a massive meatpacking plant, production drops to zero.
Yeah.
If a port union goes on strike to protest inflation, global shipping grinds to a halt. From a purely strategic standpoint, the human body has become a systemic vulnerability for heavy industry.
The human body as a systemic vulnerability, that is a chilling way to frame it. But looking at the balance sheets, I mean, the math supports the premise.
It undeniably does.
And this demographic crisis is colliding directly with the end of hyperglobalization. I mean, for the last 4 decades, the corporate playbook was so simple. If domestic labor gets too expensive or too scarce, you just offshore the dangerous, dirty jobs to countries with cheaper, younger labor pools.
But that playbook is obsolete now.
Right.
Geopolitical tensions, tariff wars, the disruptions to transoceanic shipping. It's all triggered a desperate reshoring trend.
Nations are looking at their critical supply chains and realizing they are terrifyingly exposed.
Exactly. We are seeing governments subsidize the construction of semiconductor fabrication plants, massive battery facilities, defense infrastructure, right on their own soil.
But here is the structural flaw in that political ambition. You can't build $1 trillion worth of physical infrastructure and then operate those factories without the human bodies to actually swing the hammers and pour the concrete.
You need hands-on tools.
Right. So the macro environment is absolutely screaming for a mechanized solution. Which brings up an obvious question for anyone who has followed manufacturing.
Sure.
We've had robots in factories since the 1980s. General Motors was using the Unimate robotic arm decades ago. Why haven't those legacy systems already solved this labor shortage?
Because legacy automation is fundamentally rigid.
Okay, explain that.
Those giant yellow robotic arms you see in archival footage of car factories. They're not robots in the modern intelligent sense.
Yeah.
They are highly complex automated tools.
Right.
They are entirely blind, they're deaf, and they operate on strict hard-coded kinematics.
So they're essentially physical algorithms. They just execute a predetermined sequence.
Exactly. They only know how to move their joints from precise coordinate A to precise coordinate B.
So if a car chassis on an assembly line shifts even 2 inches out of alignment,
The legacy robotic arm does not possess the spatial awareness to adapt at all. It will blindly weld empty air, ruining the product and potentially shutting down the entire multi-million-dollar line.
wow.
And furthermore, because they have zero awareness of their environment, they are incredibly dangerous.
Right. The cages.
Yes. If a human worker accidentally steps into the operational envelope of one of those caged robotic arms, the machine will not stop. It will crush the worker, simply because it lacks the sensory input to even know the human is there.
Okay, so that perfectly explains the limitations of 1980s tech. But what about the viral videos we have all seen over the last 10 years?
Ah, yes.
You know, the robotic dogs opening doors, or those bipedal humanoids running obstacle courses and executing perfect backflips. That certainly looks like advanced spatial awareness.
It creates the illusion of intelligence, for sure. But we need to strictly debunk what is happening in those early viral demonstrations.
Okay, let's do it.
From an engineering standpoint, those were magnificent.
Arthocrax.
Yeah. The Boston Dynamics videos, for instance, showcased incredible advancements in balancing and hydraulic actuation. I mean, beautiful engineering.
Right.
But those movements were pre-programmed, highly choreographed routines.
Wait, really? They weren't reacting in real time?
No, not generally. Engineers spent months writing millions of lines of code to calculate the exact physics of that specific backflip in that specific room with known traction and known gravity. The robot itself had zero general intelligence.
So if you took that exact same bipedal robot that just did a backflip and you placed it in an unpredictable, messy environment like, say, a residential kitchen, and asked it to unload a dishwasher, what happens?
It fails catastrophically.
Just completely breaks down.
Yeah, it does not know what a plate is, it does not understand the fragility of glass, and it cannot dynamically path plan around a chair that was moved 2 feet to the left.
So the hardware was there, but the brain wasn't.
Precisely.
Yep.
The engineering bottleneck for the last 30 years has not been the hardware. We've had the metal, the motors, the power systems. The failure point was the brain. The body was completely disconnected from any cognitive understanding of the physical world.
Which brings us to the massive technological inflection point of this deep dive. That 30-year cognitive bottleneck has just been shattered by the sudden arrival of foundation models for movement.
Yes. Embodied AI.
Right. We need to clearly explain the mechanism here because this is where the timeline accelerates dramatically. How did we go from hard-coded parlor tricks to generalized physical intelligence?
To understand embodied AI, you really have to look at the architecture behind large language models.
Like the text generators everyone uses now.
Exactly. A few years ago, researchers built these massive neural networks based on transformer architecture. By feeding these networks vast amounts of text, essentially the entire internet, the model learned the underlying probabilistic patterns of human language.
Right. They learned grammar, context, reasoning.
Yes. It developed an internal representation of the world based on text. Now, what engineers recently realized, and this is the absolute tectonic shift in the industry, is that a transformer model does not actually care if it is processing text.
It's just math.
Right. It is just processing sequential tokens of data. So you can take that exact same neural network architecture and apply it to physical space.
Oh, wow. So instead of the AI trying to predict the next logical word in a sentence, it is predicting the next logical physical movement required to achieve a goal.
Exactly. You nailed it. Instead of a human engineer sitting down and trying to manually code the millions of micro adjustments required to flex a synthetic wrist, grasp a doorknob, and apply the correct rotational torque.
Which is impossible to hard code for every scenario.
Exactly. Instead of doing that, they simply feed the AI model millions of hours of video data showing humans navigating the physical world.
So it just watches us.
Yeah. The AI observes humans opening doors, folding laundry, picking up tools. It processes this visual data and essentially learns the fundamental rules of physics: gravity, momentum, friction, object permanence.
Okay, but observing physics is very different than executing it. I mean, a language model can generate text on a server safely, right? If it makes a typo, no big deal. But if a physical 300-pound metal robot attempts to learn by trial and error in a real factory, it's going to destroy equipment and endanger humans. How does the model actually practice these movements safely?
That is the genius part. It happens through a deeply sophisticated process called sim-to-real transfer.
Sim-to-real.
Right. The neural network does not practice in the real world initially. It practices inside a hyper-realistic, massively accelerated physics simulation.
Like a video game engine on steroids.
Very much so. The engineers create a digital twin of the environment. And inside this simulation, the physics engine perfectly models gravity, material density, surface friction, joint limits.
So the AI attempts a task, like sorting irregular packages, millions of times inside the simulation.
Yes. And it fails millions of times.
Naturally.
But because it's in a simulation, it can run these trials at the speed of computation. It is effectively experiencing decades of physical trial and error in a matter of days.
That's incredible scale.
It is. And to prevent the AI from simply memorizing the specific simulation, they use a technique called domain randomization.
What does that mean?
They constantly change the variables inside the simulation. They alter the lighting, change the weight of the objects, shift the friction of the floor. This forces the neural network to develop generalized, robust, problem-solving skills rather than brittle, memorized routines.
And bridging that reality gap actually works. Like the physics learned in a simulation translate perfectly to the physical world.
The translation is becoming astonishingly accurate. Once the neural network has mastered the physics in the digital realm, its weights and biases, its brain essentially, are downloaded into the physical hardware of the humanoid robot.
Okay, give us some real examples of this, because the source material for this deep dive highlights several verifiable cases of this intelligence.
Sure. Well, because the AI has learned the physics of materials, it inherently understands material deformation now. It knows that a delicate glass cup requires a fundamentally different grip strategy than a heavy steel wrench.
Right. There is a specific detail in the research notes that perfectly illustrates this spatial processing. If a human throws a crumpled piece of paper at one of these modern humanoid robots, the machine will actively track the object in the air, calculate its trajectory, and catch it.
Which requires an incredible orchestration of real-time spatial mapping, predictive physics, and latency-free motor control.
It's wild.
Or consider a task that seems so simple to a human, but is historically impossible for a machine: dealing with unstructured visual data. If you place a bowl of mixed fruit in front of the robot and issue a verbal command to pick up a red apple, the robot's onboard vision language model parses the audio token. It scans the bowl using its optical sensors and isolates the specific object.
So it sees it, understands what it is, and then reaches for it.
Yes, it dynamically calculates the trajectory for its arm, actively avoiding the other fruit. And as its synthetic fingers make contact with the apple, tactile sensors embedded in the fingertips send real-time haptic feedback to the neural network in milliseconds.
Feeling the fruit.
Exactly, allowing the robot to dynamically adjust its grip pressure so it secures the fruit without bruising it.
So it's the difference between a wind-up music box that only plays one single predetermined song and a master jazz pianist who understands the underlying theory of music, reads the room, and improvises seamlessly.
That analogy perfectly captures the leap from programmed kinematics to spatial reasoning. The rigid script is gone. The machine possesses genuine situational awareness.
But engineering brilliance doesn't put robots on factory floors, chief financial officers do. Always.
Right. Which brings us to the money angle and the real-world case studies. This unprecedented deployment of embodied AI isn't being driven by executives wanting their facilities to look futuristic. It is driven by ruthless, unforgiving unit economics.
Absolutely. The balance sheet is the ultimate arbiter of technological adoption. Always has been.
So let's look at where these humanoids are being deployed right now, today.
They are going into the dull, dirty, and dangerous sectors. The primary case study we need to examine is the modern e-commerce fulfillment center.
Let's contextualize the scale of these facilities for a second. We are talking about millions of square feet of concrete under a single roof.
It's staggering, and the reality for the biological workers inside them is punishing. Human beings are walking literally miles across hard concrete floors during a single shift.
Just relentless bending, twisting, lifting.
Right. The human musculoskeletal system was simply not engineered for that volume of repetitive mechanical stress over years. Let's talk about the financial fallout of that physical toll, because it completely breaks the traditional logistics model. The sources indicate that annual turnover in some of these high-volume facilities exceeds 100%.
Yes, 100%, which means the company is replacing its entire warehouse workforce every 12 months.
That's insane.
The friction costs are massive. Every time a worker quits out of exhaustion or suffers a repetitive strain injury, the company absorbs a massive financial hit.
Right. You have the direct costs of recruiting, onboarding, training a new employee, who naturally operates at lower efficiency for the first month.
Exactly. And more critically, they face skyrocketing workers' compensation premiums, medical liabilities, and the hidden costs of shrinkage and damaged inventory due to human fatigue.
It presents a really stark human and economic contrast.
Yeah.
You have the severe physical pain of the warehouse worker on the floor, directly paralleling the sheer financial desperation of the logistics executive in the boardroom.
They are both suffering under the current model.
The CFO is just trying to figure out how to maintain supply chain velocity without destroying gross margins.
Which brings us directly to the discounted cash flow math that is driving this robotic transition. We have to compare the fully loaded cost structure of a human worker against a Generation 1 humanoid robot.
Let's run the numbers.
Let us take a conservative estimate for a human worker in a warehouse setting. Between hourly wages, healthcare benefits, payroll taxes, insurance premiums, and paid time off, that biological worker costs the company roughly $50,000 a year.
Okay, $50,000. And that human works an 8-hour shift. They require mandated rest breaks, they take weekends off, and inevitably they suffer illnesses or require vacation time.
Their productivity is highly variable.
Right.
Now run the numbers on a Generation 1 humanoid. The current manufacturing and deployment cost for these advanced bipedal machines is hovering around $100,000 upfront.
So double the annual fully loaded cost of the human worker.
Upfront, yes. But here is where the unit economics become undeniably brutal. That $100,000 asset does not work an 8-hour shift.
Right.
It operates 20 hours a day. It only allows 4 hours for automated battery swapping, data offloading, and routine mechanical maintenance.
And it works 365 days a year.
Exactly. Its output is perfectly predictable. It operates with millimeter precision at hour 19, just as it did at hour 1. It never calls in sick. It never joins a union, and it never files a catastrophic workers' compensation claim for a herniated disc.
So when a CFO runs the amortization schedule on that level of continuous, predictable productivity, the payback period collapses entirely. We're looking at a 14-month payback period, After month 14, that $100,000 capital investment has entirely paid for itself through labor displacement.
Correct. After month 14, every single hour of labor that robot performs falls directly to the bottom line. It is generating pure, unadulterated gross margin.
Unbelievable.
From a fiduciary standpoint, There is no human labor force on Earth that can compete with those long-term economics.
And we must emphasize to you listening that this is no longer theoretical modeling on a spreadsheet. Real companies are executing these deployments right now.
The pilot programs have advanced to operational integration.
Give us a specific example.
According to recent industry disclosures, major automotive manufacturers, such as BMW at their Spartanburg facility, are deploying humanoid robots directly onto the assembly line. One of the most critical use cases being tested is the installation of automotive wiring harnesses.
Why wiring harnesses specifically?
Because a modern vehicle contains miles of flexible, unstructured cabling. Threading these flexible wires through tight, unpredictable spaces inside a car chassis is notoriously difficult for rigid, caged robotic arms.
Right, because it requires tactile feedback and spatial reasoning. The wire bends unpredictably.
Exactly. But a humanoid equipped with embodied AI and tactile sensors can manipulate the flexible wiring just like a human. Furthermore, major global logistics giants are deploying humanoids to unload massive shipping containers in extreme heat environments.
Which is a brutal job.
It's a task with such a high turnover and injury rate that logistics firms literally cannot find biological humans willing to endure it anymore.
Okay, so if the macro demographics dictate a labor shortage, the neural networks have solved the intelligence gap, and the unit economics guarantee a 14-month payback. The obvious instinct for any investor or business owner listening is to rush out and buy equity in the companies building the flashiest humanoid robots.
That's usually the reflex.
Right. Find the brand names producing the bipedal chassis and allocate capital there. But this is exactly where we need to introduce our contrarian take, because buying the robot brands might actually be a trap.
It is a profound trap for misallocated capital.
Okay, let's break that down.
If we look back at the history of technological gold rushes, whether it was the literal gold rush of the 1840s, the personal computing boom, or the recent generative AI explosion, the entities that generated the most reliable, outsized wealth were rarely the consumer-facing brands fighting brutal price wars.
Right. It wasn't the miners. It was the people selling the picks and shovels.
Precisely. The wealth accrued to the merchants. The humanoid robotics industry will follow this exact pattern. The smartest capital is not betting on which specific brand of bipedal robot will win the factory floor.
Because that's going to be a race to the bottom on pricing.
Exactly. The smart capital is betting on the deep, highly specialized, and deeply constrained hardware supply chain.
Which brings us back to the loop we opened at the very beginning of this deep dive. Who actually controls the hidden microscopic components?
That's the billion-dollar question.
Because if the global economy is going to manufacture 50 million humanoid robots by 2030, we are going to hit an unprecedented hardware bottleneck. The specialized manufacturers that produce these components are going to hold the world economy hostage.
They absolutely will.
Let's break down the mechanics of these bottlenecks. Let's start with how the robot actually moves. Let's look at the joints.
So in the robotics industry, the joints are referred to as actuators. Now, to replicate the fluid grace, the speed, and the incredible strength of a human arm or leg within a compact form factor, you cannot simply use cheap, off-the-shelf industrial motors.
It wouldn't work.
No, they are too bulky. You require highly specialized high-torque, low-weight rotary, and linear actuators. These components are absolute engineering marvels. They pack immense rotational force into a cylinder the size of a coffee cup.
And they require specific metallurgical and elemental inputs, correct?
Yes, heavily. To achieve that high magnetic flux density and torque in such a compact size, these advanced actuators rely on rare earth permanent magnets, specifically neodymium magnets.
And this introduces a massive geopolitical choke point.
A massive one. The mining, refining, and advanced processing of neodymium is overwhelmingly controlled by a single geopolitical superpower, China.
Right.
If that supply chain is restricted through tariffs, export controls, or geopolitical conflict, the mass production of humanoid robots globally grinds to an absolute halt.
So the component manufacturers that can either secure reliable sourcing of these rare earths or innovate alternative high-torque magnetic designs without them possess incredible leverage.
Infinite leverage. That is bottleneck one.
Okay, what is the second major hardware constraint?
The second, and perhaps most difficult, bottleneck to overcome from a pure manufacturing standpoint involves harmonic drives and precision gearboxes.
Let's explain why they matter so much.
When a humanoid robot extends its arm to hand a tool to a human worker, that motion must be perfectly smooth and precise.
You can't have it jerking around.
Right. You cannot have the arm trembling or suffering from what engineers call backlash.
Backlash is basically the slight play or looseness between gears, right?
Exactly. To achieve zero backlash power transmission from the electric motor to the physical limb, you require a harmonic drive, also known as strain wave gearing.
Explain the physics of a harmonic drive, because I know it is not just two gears grinding together. Why is it so difficult to manufacture?
It is a brilliant piece of mechanical engineering, actually originally developed for aerospace. A harmonic drive relies on three main components, but the critical one is the flex spline.
The flex spline?
Yeah, it's a thin, flexible metal cup with gear teeth on the outside. Inside this cup is an elliptical plug that constantly deforms the metal cup as it rotates, forcing its teeth to mesh with a rigid outer ring.
Wow, so it is literally bending metal continuously to transfer power.
Exactly. And the metallurgy required to create a steel alloy that can deform and flex millions of times under heavy loads without suffering molecular fatigue failure is just staggering.
I can imagine. The machining tolerances must be microscopic.
They are. If there is a single microscopic flaw in the forging or the heat treatment of that flex spline, the metal will eventually snap. The robot's knee will fail, and a 300-pound machine crashes to the factory floor.
Which means you cannot simply spin up a new manufacturing plant in 6 months to start churning these out.
Not at all. It requires decades of institutional knowledge to get that metallurgy right.
Yeah.
As a result, there is a massive global shortage of high-end harmonic drives.
Who controls it?
The intellectual property, the patents, and the deep metallurgical know-how are held by a tiny oligopoly of deeply entrenched companies, primarily located in Japan, Europe, and the United States.
So they have an absolute stranglehold on this critical component.
If you want to build a functional bipedal robot, you must pay their toll.
Okay, actuators, harmonic drives, and there is one more vital component we touched on earlier when we discussed the robot picking up the red apple without crushing it: the digital skin.
Yes, tactile sensing arrays. A traditional industrial robot is encased in hard plastic or rigid aluminum, right? It is entirely numbed to the world.
It feels nothing.
Right. But for embodied AI to function in unstructured environments, to interact safely alongside biological humans and manipulate delicate objects, it requires profound tactile feedback. The robot needs a digital skin embedded with thousands of microscopic pressure, shear, and temperature sensors.
Explain the mechanism behind this. How does a piece of synthetic rubber translate the feeling of a ripe tomato into digital data?
It relies on advanced piezoelectric sensors and highly complex, flexible printed electronics. Certain crystalline materials exhibit the piezoelectric effect, meaning they generate a distinct electrical voltage when placed under mechanical stress or pressure.
Okay.
So by embedding thousands of these microscopic sensors into a flexible polymer that wraps around a robotic fingertip, any pressure applied to the object generates an immediate electrical signal.
And the brain processes that.
The neural network processes these signals in milliseconds, allowing the robot to feel resistance and adjust its grip dynamically.
The specialized manufacturers developing these tactile sensing arrays and flexible printed circuits are perfectly positioned then. As the demand for humanoids scales from the thousands into the tens of millions, the revenue charts for these sensor companies are going to just go vertical.
That is exactly right. So the core takeaway for the investor listening is this: do not get distracted by the flashy viral videos of robots doing parkour.
Look at the boring stuff.
Look at the highly specialized industrial suppliers manufacturing the high-torque joints, the zero backlash precision gears, and the microscopic piezoelectric sensors. They are the toll booths of this entire technological revolution.
Because if you control the toll booth, you collect a fee on every single robot built, regardless of which brand ultimately dominates the market.
Exactly.
All right, so we understand the demographic catalysts, the neural network breakthroughs, and the deep supply chain bottlenecks. Let's move to the actionable wealth playbook. How does a business owner, a systems integrator, or an entrepreneur actually position themselves for this massive shift?
Let's get into it.
Not 10 years from now, but this week, this month, or this year.
The most actionable commercial shift happening right now is a fundamental restructuring of how physical labor is financed. We are watching a massive transition away from capital expenditure, or CapEx, and toward operating expenditure, OpEx.
Let's define the difference in this context because it changes the risk profile entirely for a business owner.
Historically, if a manufacturing facility wanted to automate a packaging line, it was a massive CapEx nightmare. The factory had to take on significant corporate debt to spend perhaps $50 million upfront on a permanent, rigid fleet of bespoke machines.
Which is a massive financial risk. If consumer demand shifts or the product packaging changes a year later, those expensive machines might become instantly obsolete.
Right, leaving the company with stranded assets and massive debt.
Factories hate rigid, irreversible capital risks. So how does the humanoid robotics industry bypass this friction?
By adopting the exact same economic model that made cloud computing software so incredibly lucrative, software as a service, but applied to physical labor.
Robotics-as-a-Service, or RAS.
Exactly. Under the RAS model, the factory does not purchase the $100,000 robot at all. The robotics manufacturer retains full ownership of the physical hardware on their own balance sheet.
So they bear the hardware risk.
Yes, they maintain the fleet, they handle the mechanical repairs, and crucially, they push over-the-air software updates to the robot's neural networks, making the workforce smarter and more capable every single month.
So what does the factory actually pay for?
The factory simply pays an hourly rate for the labor output. There is essentially leasing productivity. Right now, based on early pricing models, the target rate being pitched to logistics firms is roughly $8 an hour for the robot's labor.
$8 an hour. That is brilliant from an adoption standpoint. It completely removes the capital barrier. A factory manager can scale their workforce up to meet holiday demand or scale it down during a recession instantly without taking on a single dollar of debt.
And for the robotics manufacturer, it creates a highly sticky, recurring revenue stream. But this brings up the friction you mentioned earlier.
All right, let me challenge this model for a second. If I am running a logistics warehouse and I lease 50 humanoids at $8 an hour under a RAN's contract, and my direct competitor across the street does the exact same thing, our labor costs hit absolute parity.
Correct.
Doesn't this just trigger a race to the bottom where the local business owner loses their competitive advantage? And the only entities actually capturing the wealth are the 3 or 4 Silicon Valley robotics monopolies holding the lease contracts.
That is a highly astute critique, and it's precisely the vulnerability in the model for the factory owner. If labor costs trend towards zero globally, labor is no longer a competitive moat.
Right.
Your competitive advantage shifts entirely to logistics, routing, energy costs, and system uptime, which actually creates the massive B2B opportunity hiding in plain sight.
Let's outline the steps for the playbook then.
Step 1. Recognize that the robotics monopoly is located in California cannot effectively service machines deployed in Ohio, Texas, or Germany.
Oh, that makes sense.
If a mid-sized logistics company signs a RAS contract and has 50 humanoids walking the floor, what happens when a robot trips over a misplaced wooden pallet and shatters its knee actuator? Or what happens when the manufacturer changes the visual branding on a cardboard box and the robot's vision language model gets confused and halts the sorting line?
Right. The robotics company isn't going to fly a technician out from San Francisco for every mechanical hiccup or localized software glitch. The downtime would destroy the client's operations.
Exactly. Step 2. Establish localized integration and maintenance firms. The factory needs immediate on-site support. This is where a massive new service industry is going to be born.
Like the IT boom.
Think about the IT boom in the late 1990s. Every corporation suddenly installed complex local area networks and servers, which created an absolute army of managed service providers, local IT firms, who held lucrative retainer contracts just to keep the corporate networks running.
So the physical AI boom requires an army of robot mechanics, deployment specialists, and systems integrators.
Step 3. Specialize in the integration of digital skins and vision models. Firms that understand how to quickly swap out a damaged harmonic drive, recalibrate a piezoelectric tactile sensor, or fine-tune a localized vision language model for a specific messy warehouse environment are going to be indispensable.
Wow. And step 4.
Step 4. Secure preventative maintenance contracts. It is a multi-million-dollar B2B service opportunity that requires high technical skill and mechanical aptitude. But crucially, it does not require you to invent the core foundation models or manufacture the hardware yourself.
You become the indispensable middleman keeping the automated economy online.
Exactly.
We have covered the efficiency, the profit margins, and the wealth-building integration strategies, but as promised at the top of this deep dive, we must pivot to the macro consequences. We cannot analyze this impartially without looking at the massive looming shadows. Replacing 50 million physical jobs by the year 2030 is not just an efficiency metric on a corporate spreadsheet.
No, it's not.
It is a societal earthquake. We are looking at the rapid unraveling of a 200-year-old social contract.
It is arguably the most disruptive macroeconomic event we will witness in our lifetimes, and the velocity of this transition is what makes it so perilous. Let us define the social contract that is breaking.
Please.
Since the dawn of the Industrial Revolution, the fundamental stabilizing premise of modern capitalist society has been this: if you are willing to show up, work hard, and perform physical labor, you possess economic leverage. Your physical output guarantees at least a stable middle-class existence.
That has been the great economic equalizer. The automotive factory job, the warehouse logistics role, the heavy machinery operator, these roles were the primary engines of social mobility for the vast majority of the population who either lacked the financial means or the personal desire to pursue advanced academic degrees.
Right.
Physical labor had intrinsic market value. If you had a strong back and a strong work ethic, you could feed a family and buy a home.
But we must analyze the math. If humanoid robots operating on leased Robotics-as-a-Service contracts at $8 an hour and working 20 hours a day drive the financial cost of physical labor down to effectively zero, what actually happens to the human working class?
The intrinsic value of human physical leverage drops to zero.
Exactly. And when that happens, you see a complete loss of social mobility for millions of people simultaneously. And we have to understand that this displacement will not be spread evenly across the country.
It's going to be hyper-localized.
It will be fiercely concentrated. We're going to see acute, localized economic depressions.
Let's model out a specific scenario to understand the macroeconomic chain reaction here. Consider a mid-sized town in the industrial heartland, say, the American Midwest or the British Midlands. A town whose entire local economy is anchored by a single massive manufacturing plant or a major retail distribution center.
Okay, let's say the plant employs 2,000 biological workers. The economic multiplier effect of those wages is what keeps the town alive.
Right.
Those 2,000 workers take their paychecks and spend them at the local grocery store, they buy cars from the local dealership, they eat at the local restaurants, and they pay property taxes that fund the local school district. It is a fragile, interconnected ecosystem.
Now, what happens when the corporate board of that single plant decides to deploy 2,000 humanoid robots and transitions to a fully automated, OpEx-driven RAAS model?
The localized economy experiences sudden cardiac arrest.
Just flatlines.
The wages that used to flow into the community vanish virtually overnight. The local grocery stores see their revenue plummet and close. The restaurants fail. The local mechanics go out of business. Because the property values crash, the tax base for the local schools evaporates.
The town is hollowed out.
Yes. But crucially, the wealth generated by that factory did not disappear. It was simply exported. It was transferred out of the local community and directly to the shareholders of the corporation and the robotics monopoly, headquartered in a coastal tech hub.
And when you hollow out a community economically and sever their ability to provide for themselves through hard work, you inevitably trigger a massive, volatile political backlash.
The political ramifications are staggering, and we must view this impartially through the lens of historical populism. We have seen populist movements rise significantly over the last decade, largely driven by the slow structural changes of globalization and early software automation.
Yeah.
But the psychological impact of seeing a fleet of literal bipedal machines walking into your local factory and permanently taking over the production line, that will make current political divides look incredibly mild. The anger, the feeling of disenfranchisement, and the sheer desperation will be profound.
Which means governments will be forced to react aggressively, because the state ultimately requires social cohesion and a functioning tax base to survive. If you have mass, permanent unemployment and localized depressions, the state has no choice but to intervene in the free market.
We are impartially reporting on the absolute necessity of these upcoming legislative battles. Governments will be forced to grapple with radical economic policies that are currently viewed as fringe. You will absolutely see serious legislative pushes for robot taxes.
Robot taxes, like taxing the machine?
Exactly. Policies aimed at literally taxing the labor output of an automated machine to offset the loss of human income tax and fund social safety nets.
But let's dig into the macroeconomic consequences of the most discussed solution: universal basic income, or UBI. Because UBI is often framed as a utopian ideal where everyone is given a stipend to pursue art and leisure. But in this scenario, UBI isn't utopian. It is a desperate macroeconomic patch.
It becomes a mathematical necessity to maintain the velocity of money. Our entire consumer-driven capitalist cycle relies on the equation that workers earn wages and then use those wages to purchase the goods that the factories produce.
Right.
If the robots are producing all the goods at near zero marginal cost, but the human population has no wages to purchase those goods, consumer demand collapses. The factories would have no one to sell to.
The cycle breaks entirely, so UBI might be pitched to the corporate elite simply as a mechanism to keep consumer spending alive. But here is the friction. If the localized economy is dead, and the factory is paying its lease to a Reyes company in California, where does the federal government generate the massive tax revenue required to fund a UBI program for tens of millions of displaced workers?
That is the trillion-dollar question that current economic models fail to answer adequately. You would require unprecedented taxation on corporate automation, which corporations will fiercely lobby against. Furthermore, even if you solve the mathematics of UBI, you cannot easily solve the sociological crisis.
Because it's not just about money.
No. Providing a basic stipend covers caloric survival, but it strips away the psychological purpose, dignity, and structure that physical labor provided to millions of people. The societal implications of permanently decoupling human labor from economic survival are incredibly complex, and our legislative institutions are entirely unprepared for the velocity of this transition.
And the fallout isn't just domestic. If we zoom out to the 10-year outlook, this technological shift completely destabilizes the global stage as well. Physical AI is no longer just a corporate efficiency tool. It has escalated into a geopolitical arms race.
It is the new space race, but with immediate existential economic consequences. The reality is that the sovereign nation that achieves physical AI supremacy first will absolutely, undeniably dominate global manufacturing.
Let's run a hypothetical to illustrate this dynamic because the strategic implications are terrifying. Imagine country A and country B.
Okay, let's say country A heavily subsidizes its domestic robotics industry, secures the supply chains for neodymium magnets and harmonic drives, and masters embodied AI. They reach a state of a total economic independence.
Wow.
They can now build fighter jets, nuclear submarines, advanced consumer electronics, and critical medical supplies using a 24/7 automated workforce whose operational cost has plummeted to, let's say, $2 an hour at scale.
And country B failed to invest in physical AI. They are still relying on traditional biological labor, dealing with wage demands, healthcare costs, shifting demographics, and supply chain vulnerabilities.
Country B simply cannot compete in the global market. The economic disparity becomes mathematically insurmountable. Country A will see the cost of its manufactured goods plummet, allowing them to capture total global market share and export deflation.
But more importantly, the strategic and military leverage of the automated nation becomes absolute.
Yes, they are no longer constrained by the size of their working-age population. They can scale industrial and defense output infinitely, bounded only by their access to electricity and raw materials.
Furthermore, this completely destroys the development model for the global South. For decades, developing nations industrialized by offering cheap human labor to Western corporations. If a robot in Ohio works for $2 an hour, there is zero economic incentive to offshore manufacturing to a developing nation.
Exactly. The ladder of industrialization is pulled up entirely, which explains why we are seeing unprecedented, massive, state-sponsored subsidies flowing into robotics and AI companies right now, specifically from major global superpowers. Governments are not looking at humanoid robots as a cool commercial product or a warehouse efficiency tool.
They view the mastery of physical AI as a fundamental matter of national defense and sovereign survival.
If you lose the robotics race, you lose your manufacturing base. If you lose your manufacturing base, you lose your ability to build defense infrastructure. The stakes over the next decade are quite literally the balance of global power.
We have covered an immense amount of ground today, moving from the microscopic physics of tactile sensors to the macroeconomic fate of the working class. Let's pull all of this together and crystallize the 3 key takeaways from our deep dive. Number 1, the physical AI boom is not just a technological vanity project. It was forced by a catastrophic demographic labor shortage. The combination of the silver tsunami, collapsing birth rates, and the strategic vulnerability of biological supply chains made automation an existential necessity.
Number 2, the 30-year cognitive bottleneck has been solved. By applying foundation models to physical movement through embodied AI and bridging the reality gap using hyper-accelerated sim-to-real transfer, robots have evolved from blind, hard-coded tools into systems capable of general physical intelligence and real-time improvisation.
And number 3, The true wealth in this revolution lies beneath the surface. It will be captured by the Robotics-as-a-Service leasing models that shift CapEx to OpEx, the local integration firms that maintain the fleets, and crucially, the hardware monopolies. The deeply entrenched companies that control the high-torque actuators, precision harmonic drives, and piezoelectric sensors are the toll booths of the future economy.
That's where the leverage is.
But I want to leave you with a polarizing question to consider, because the mathematics of this transition will affect every single one of us. If a humanoid robot can work 24/7 in a factory, bringing the marginal cost of physical labor down to $5 an hour, what actually happens to the human working class? Are we heading toward a post-scarcity utopia of absolute material abundance? Or are we accelerating headfirst into a dystopia of massive human displacement and hollowed-out communities? Drop your thoughts in the comments. We read every single one of them, and your insights help shape the friction in these conversations.
It's the conversation we all need to be having.
If this deep dive helped you understand the unit economics and the systemic risks of the physical AI gold rush, make sure you subscribe. And please, share this with an investor, a founder, or a systems engineer who needs to understand exactly how the hardware supply chain is bottlenecking the future.
It's crucial data.
Because next time we are pivoting away from the factory floor and looking directly at the human body, we are going to dive into the AI longevity clinic, unpacking the specific neural network architectures that are collapsing the global drug discovery timeline from 10 years down to just 10 months, and the staggering margins involved. It is going to challenge everything you know about biotech. Until then, stay curious, stay positioned. And as always, remember that everything discussed today is for educational purposes, not financial advice. Do your own research.